Oh hey Armstrong kids, it's your boy Mr. Summers coming to you from the COVID-19 bunker of my palatial Edina estate. Um, Jeevesy brought me some tea, and we're just going to hang out and go through what a virus means. What does that term mean, since it's hot news these days? Here we go. If you didn't piece it together, um, a virus is a not living thing that is a kind of an infectious tool made out of parts of normal macromolecules that people use in their daily lives, but in itself is not alive. It doesn't do some things that you need to do to be alive. So let's go through what that means. First, virus is Latin for the word poison, and then typically viruses have one or the other, either DNA or RNA, but definitely not both, surrounded by something that allows them to attach to something. And that something is a protein coat. And then they use your cell organelles to be able to then replicate themselves. They're not really doing much of the work. They're just infecting and changing you into things. Most of the viruses you see are in this range: polyhedral or helical or complex. This one right here is the sweet, sweet Ebola virus, in case you can't read what that says. Polyhedral can come in any number of shapes, but they're like a little tiny rod things around the outside, or the inside has the DNA, or these lunar landing pods over here, my personal fave, because they look like they're what Neil Armstrong used to land on the moon. But in all actuality, they are just something that attaches to your cells and then can inject into its piece of DNA, the real treats. Viruses are not alive. Since they don't do a couple things, there's no growth, they are assembled. There's no infant phase of a virus. It is just pieces put together. They don't eat. There's no metabolism there. There's nothing they're digesting. There's no energy being used by the virus that they themselves are bringing in. They're just using the bits around them. And they do not maintain any sort of homeostasis. There's no internalized conditions in a virus to maintain being the same. They do have a lot of like qualities, but they're not themselves alive, right? They can infect you because they are made of the same stuff as you, but not all the pieces needed to make a living thing. I feel like this view right here just makes me look just phenomenal. I shaved my beard, it's growing back though. I look great, in case you're wondering. Viruses are very specific. Like the human immunodeficiency virus, HIV, doesn't affect my dog. And then whatever viruses that Luca can get doesn't affect me normally. They replicate so fast and can change so easily is how you can see stuff moving across species. The flu is a virus, right? So there are viruses that can start in one species but change, mutate, I would say the best way to describe it, so they can infect others. So that's why there was like that bird flu scare a while ago, or the other one, what was it? Swine flu came from pigs. Like those things can happen because they can change their DNA pretty quickly. There are ones for plants. And then viruses have to actually attach onto a cell, right? Which is what all the big stuff about washing your hands, not touching your face and eyes or mouth, with the COVID-19, because it's not going to get into the cells on your fingers so much as it will the lining of your respiratory system, which makes it so dangerous, which is why if one lands on your hand and you wash your hands, nothing happens. If you put it into a place where it can replicate, it is much, much worse. So I have to attach it in there. Look at this little, I don't even know what that is. The shape of it, which it makes it so dangerous, are viruses. They're made of the same rough materials as the outside of your cells, so they get recognized as a protein and can be brought in through processes like endocytosis, and other things like that, because it's the same stuff, right? So if it is going through, the process of being brought into your cells, and your cells think it's one thing and it's really just something else, it's not quite ideal for you. And that is, again, why viruses are dangerous, because they're bits of stuff that is relatively close to the same stuff that you're trying to bring in, except they have their own DNA or RNA and then can start taking over cells and making more copies of things. Don't worry, I washed my hands before I touched my eyes. I'm in my own palatial bunker estate. What does it even matter these days? Two different ways viruses reproduce. Lytic cycle is like, I'm going to sum it up in less than this amount of steps because it's super easy. It is attach, inject, make more, breakout, right? It is gangbusters. It is, I have no flu yesterday and I am sick today because these things happen, right? So the lytic cycle is, and I'll show you in the picture on the next screen, again, it is attach. Here we go, right? They even made this like 5 steps in this photo, right? Attach, make more, bust out. 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 Viruses are ridiculously tiny, right? Like, if you were thinking about it, that you can have roughly 10 bacteria cells per every one of your real cells in your body. Viruses, you can have hundreds inside a bacteria cell. So you have thousands you could possibly make inside one of your cells. It's really small. They're insanely small. And so when you're making these copies, it's not like this picture where you're making, 5. You're making 1,000. And if they're busting out and attaching to new cells, your head's going to grow at an astronomical rate. Look at that. Astronomical rate just for you guys. I'm going to move me to here just because now I spice some things up 7 minutes and 22 seconds into this bit. There it is, though. So again, lytic cycle. I am not sick with the flu. I have the flu the next day. Flu is lytic cycle, in case you didn't piece it together. It is attach, make more, bust out, attach, make more, bust out, attach, make more, bust out, attach, make more, bust out. And if every one of these 5 makes it to another cell and they can attach and make more, bust out, you are growing super speed. Lysogenic, way worse, right? HIV uses lysogenic as its replication method, and it is not attach, make more, bust out. It is attach, and then like get into your DNA, which is not ideal, right? So if it integrates into the host DNA, then every time the host replicates its cells, like nothing's happening, you are making more virus DNA, right? So that's the process. And I'll show you in this sweet pic because there's a lot more. Really hard to get rid of something that is stuck inside of your DNA, right? Like every cell that replicates is copying the virus DNA. It's not making viruses, it is making copies of virus DNA that can later on down the line become virus cells. They're not even cells, they're just viruses, right? So it's a lot harder to get rid of. Again, HIV is a lysogenic cycle. So let's go through the picture because that's the part that matters, right? So this is the little piece of DNA, and this is a bacteria we're looking at here, right? So virus lands on bacteria, and then notice this little black piece of DNA here now is the virus DNA. And every time the cell divides, like going through mitosis, well, bacteria cells, like something else, fission, right? So every time this happens, it copies this DNA. So now this one cell, in the course of its lifespan, right, is just making boatloads more of virus DNA over and over again because the cell is going to keep copying like nothing's going on. And that's terrible because then eventually you'll get to a point in time where it will do the lytic cycle, but now you've got millions of cells that have virus DNA in it that can then become lytic, and it's just no bueno. I never took Spanish. I took Russian. 2 years. I probably can't even say no. Neat. Yeah, I got it. There it was, just for you guys. So again, that's the process. So you're looking at it like, as you're looking through me narrate this sweet photo for you, right? DNA gets incorporated into the host DNA. Now notice that this one's like dark blue, light blue here, right? Every time this cell divides down the line, it is copying virus DNA. If something triggers it, now you've got lytic cycle happening. And in the case of HIV, this is the AIDS part of it. This is acquired immune deficiency syndrome out here, and this is HIV. Obviously, the term anti-antibiotic means not living, so you can't kill viruses with antibiotics because they only work on living things, and viruses are not allowed. So they don't prescribe you, amoxicillin, erythromycin, or any of the other ones you looked in that bacteria lab when you have a virus. They don't give you for the flu. They can kind of like try to inhibit the virus's ability to attach to cells, but that's not going to work as well. Vaccines are the easiest way. You have a series of them. I know that right as this all hit, we took Clark to go to the doctor because his vaccines needed to be up by a certain day. So he got flu vaccine. He got some other weird stuff that I never heard of, right? Probably measles, mumps, and rubella. What they do is they give you a little piece of the outside part of the virus and that are weakened so that your body then can make the needed antibodies to fight it, and it works. So then if that same virus comes towards your cells again, you've already fought it off and won. So you know what to do because it's not changing, right? With the flu vaccine, so if you get the flu vaccine every year, why do you need to get the flu vaccine every year? Because it's not just one flu. Influenza is a group of viruses. So the CDC normally takes data of trying to give you the 7 most common forms. And so if you get the 8th most common form of the flu after you've had the flu vaccine, you still get the flu, right? So it's still the same concept. You need to get that specific one onto your body then to be able to then fight it off with that. And you'll learn that in the sweet immunity system, the immune system, which I think is the next unit. I don't remember. Anything else? Hold on, wait. Eventually we're going to watch this flu video, maybe, I think. Hey, look, guys. That's where it ends. Mr. Summers, best male biology teacher in this building. True story, I'm the only one, so I'm also the worst. Miss you all so dearly. Hold on, I'm going to make myself big so I can look amazing. Man, I look amazing. I'm just going to smile at myself for the next 10 minutes. Hey, stay safe, everybody. Wash your hands.